What if everything you know about your place in the cosmos is wrong? Imagine a silent ballet, thousands of unseen dancers pirouetting above us, held in an eternal embrace by an invisible force. This isn't magic, it's the profound truth of how satellites stay in orbit, a secret whispered by the universe itself. The paradox of gravity, falling without end. What if I told you? Satellites don't actually fly, they fall? They fall endlessly around Earth, a perpetual descent, yet they never hit the ground. This is the breathtaking paradox at the heart of orbit. It's where gravity, the very force that pulls us down, instead holds these marvels perfectly suspended. They are caught in the silence of space, a delicate balance between descent and forward motion. If you believe the universe still holds countless mysteries waiting to be revealed, hit subscribe to Space Facts Lab now. Because every video here opens a doorway, not just to outer space, but to the very nature of existence itself. If you love uncovering the hidden patterns of the cosmos, don't forget to subscribe. Join us as we unravel the cosmic tapestry, one profound truth at a time. Subscribe for more cosmic truths. Hashtag Space Facts Lab, hashtag Universe Explained. From an apple to a satellite, Newton's cosmic vision. Our story begins not in the stars, but in a quiet 17th century garden. Here, Isaac Newton watched an apple fall to the ground, a seemingly mundane event that sparked a revolution in human thought. He asked himself a simple but revolutionary question: what if you could throw that apple fast enough so that it never landed? Would it then fall forever, tracing an endless arc around the Earth? From that single, audacious question came the law of universal gravitation. This groundbreaking law opened the first door to the space age, forever changing our understanding of the cosmos. Newton realized that the same invisible force pulling the apple down also keeps the moon in orbit around the Earth. It's the same majestic power that holds our Earth itself in its grand journey around the Sun. 3 centuries later, in 1957, humanity put Newton's brilliant idea to the ultimate test. The Soviet Union launched Sputnik 1, a small, gleaming metal sphere that circled Earth every 96 minutes. In that pivotal moment, Newton's elegant equations leapt off the page and into reality. Humanity had begun its extraordinary journey beyond the atmosphere, propelled by a simple, yet profound, understanding of gravity. The music of gravity, when falling becomes flight. What if everything you thought you knew about the sky was wrong? What if flying isn't about escaping gravity, but about surrendering to its pull with perfect precision? Imagine standing atop the highest mountain, a vantage point where the curvature of the Earth becomes visible. Now, throw a bullet as fast as you possibly can. Throw it softly, and it arcs briefly before falling to the ground, a victim of gravity's relentless tug. Throw it harder, and it flies farther, defying gravity for a longer moment before its inevitable descent. But here's the cosmic secret: throw it fast enough, about 7.9 kilometers per second, and it will keep falling. Forever. It will continuously miss the Earth, perpetually circling its curved surface. This incredible speed is known as orbital velocity, the first cosmic speed. It's the magical threshold where falling down transforms into falling around, a continuous, graceful descent. At this precise velocity, an object ceases to be a mere projectile and becomes a satellite. It enters a state of perpetual freefall, perfectly balanced between the Earth's gravitational embrace and its own forward momentum. Different altitudes demand different speeds to maintain this delicate balance. In low Earth orbit, LEO, where the pull is strongest, satellites need to hurtle at approximately 7.8 kilometers per second. Higher up, in medium Earth orbit, MEO, the gravitational pull is slightly weaker, requiring a speed of about 3.9 kilometers per second. And in the distant geostationary orbit, GEO, the required velocity drops to around 3.07 kilometers per second. Orbit is not flight in the conventional sense, it is a perfect, unending fall. It's a breathtaking dance between the Earth's powerful gravitational pull and the satellite's relentless forward push, a cosmic waltz choreographed by the laws of physics. Curiosity is what keeps us in orbit. Let's explore together. Subscribe to Space Facts Lab to keep your mind in motion around the wonders of the universe. The cosmic symphony above us, types of orbits. Look up at the night sky, and there you see nothing. Imagine it. Above your head, tens of thousands of satellites are engaged in an intricate, silent dance. They are not all moving in the same direction, nor at the same height. Each one moves with a specific purpose, with breathtaking precision, and with a silent poetry that speaks volumes about human ingenuity. Each orbit is a distinct note in the grand symphony of the cosmos. Low Earth orbit, LEO, ranging from 160 to 2,000 kilometers above the surface, is a bustling highway. This region is home to Earth observation satellites, constantly monitoring our planet's health, tracking weather patterns, and powering vast satellite internet constellations like Starlink. Further out, from 2,000 to 35,000 kilometers, lies medium Earth orbit, MEO. This is the domain of global navigation systems, the silent architects of our modern world. Here, constellations like GPS, GLONASS, and Galileo guide our journeys, ensuring we always know where we are. At a precise altitude of 35,786 kilometers, we find geostationary orbit, GEO. Satellites here appear motionless in the sky from our perspective on Earth. This unique vantage point makes them perfect for broadcasting television, providing continuous communication, and delivering vital weather data. Then there are the polar orbits, where satellites sweep over both the north and south poles on each revolution. These intrepid explorers capture images and data of the entire planet every 24 hours, providing a comprehensive view of our ever-changing world. Each type of orbit, with its unique characteristics and purpose, contributes to the intricate harmony of our technological age. It's a testament to humanity's ability to harness the fundamental forces of the universe. You've just seen how falling can become freedom, how a simple scientific principle underpins our modern world. Let your curiosity never stop falling, either. Press subscribe, and join us as we journey deeper into the universe, where science and philosophy intertwine, revealing the profound connections between the cosmos and our own existence. Join the cosmic journey. #SpaceFactsLab. The challenges of space, when satellites are no longer alone. But space, once a vast and silent frontier, is no longer quiet. Every year, thousands of new satellites join this celestial dance, each one a testament to our relentless progress. Yet, with this progress comes a growing shadow: space debris. Broken satellites, discarded rocket fragments, and countless shards from past collisions now hurtle through orbit at terrifying speeds. These fragments, often no bigger than a coin, travel at over 28,000 kilometers per hour. At such velocities, even the smallest piece of debris can strike an active satellite with the force of a hand grenade, destroying it instantly. This escalating threat is why agencies like NASA, ESA, and SpaceX meticulously track these objects. They constantly predict potential collisions, adjust satellite orbits, and work tirelessly to prevent a catastrophic chain reaction. One major crash could generate thousands of new fragments, triggering a domino effect known as the Kessler syndrome. Such an event could render Earth's vital orbits unusable for decades, isolating us from the very technologies we now depend on. Progress, it seems, always comes with its own paradox. In our quest to connect the world and explore the cosmos, we are slowly, inadvertently, transforming Earth's pristine orbital highways into a graveyard of our own creations. Satellites, the eyes and heart of humanity. Every satellite above us is a profound symbol of balance, a delicate equilibrium between fall and flight, between order and chaos, between the relentless pull of gravity and the graceful dance of motion. To truly understand orbit is, in a way, to understand ourselves. Satellites are humanity's distant eyes in the cosmos, constantly observing, learning, and transmitting. Yet, they are also powerful mirrors, reflecting back to us who we are, what we value, and what we aspire to achieve. From the very first breathtaking photo of Earth seen from space, a blue marble suspended in black, to the precise GPS signals guiding our daily lives, the accurate weather forecasts protecting our communities, and the global communication networks connecting billions, these silent dancers have profoundly shaped our civilization. Each satellite tells a story, a narrative of human ingenuity, insatiable curiosity, and unwavering courage. They are testaments to our drive to push boundaries, to understand the unknown, and to connect across vast distances. They remind us that to truly fly, we don't always need to escape the forces that bind us. Sometimes, we simply need to learn how to fall in the right direction, embracing the forces of the universe to achieve new heights. If you love exploring how science reveals the poetry of the universe, subscribe now. Let's keep unraveling the mysteries of the cosmos together. Lessons from orbit, the symphony of existence. When you look up at the night sky, remember this profound truth. Thousands of satellites are quietly circling above you, unseen but ever present. There is no sound, no dazzling light show, just silent performers in an endless, intricate dance of physics. Orbit isn't merely a scientific concept, it's a powerful metaphor for life itself. It embodies the delicate balance between gravity and freedom, between the forces that hold us down and the aspirations that allow us to soar. The universe, in its infinite complexity, is not chaos. It is a symphony, delicate, precise, and eternal. And we, fragile as we are an integral part of that magnificent cosmic music, playing our own unique note. Next time you look up at the stars, if you feel small yet deeply connected to something vast and wondrous, hit subscribe, and keep exploring with us. Because understanding the universe, in all its grandeur and mystery, is another way of understanding yourself. Discover more cosmic perspectives with Space Facts Lab. Let your mind wander among the stars. Keep watching Space Facts Lab, where every question is a new journey into science, wonder, and the boundless human spirit. Subscribe for more cosmic truths. Hashtag Space Facts Lab, hashtag Universe Explained.